Welcome to the unit on constant acceleration. In this unit, we will be looking at key concepts through review exercises. The objectives for this session are to review previous topics through exercises, namely, find the gradient of straight line graphs, find the shaded area under a straight line graph, apply the speed distance time formula to real-life problems, and solve simultaneous equations and quadratics. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. We begin by recalling the rule for integrating kx to the power n. If f dash of x equals kx to the power n, then we have that f of x equals k over n plus 1 times x to the power n plus 1 plus c, where n does not equal minus 1 and c is a constant. When integrating polynomials, apply the rule for integration separately to each term. We will now take a look at definite integrals. If f dash of x is the derivative of f of x for all x in the interval ab, then the definite integral is defined as integral from a to b f dash of x dx equals f of x between b and a, which equals f of b minus f of a. We will now take a look at the steps for integrating definite integrals. First, write the definite integral statement with its limits, as shown. Next, integrate and write the integral in square brackets, as shown. And finally, evaluate the integral by working out f of b minus f of a. The area between the positive curve y equals f of x, the x-axis, the line x equals a, and the line x equals b, as shown in the diagram, is equal to the integral between the limits a and b of y with respect to x. Let's now take a look at review exercise 1. In the graphs below, find the gradient and the equation of the straight line and the area of the shaded region. Let's look at the first graph. Gradient, remember, is change in y over change in x. So in this graph, it is 10 minus 2, representing the change in y, divided by 4 minus 0, which gives us 8 over 4, which equals 2. So the gradient of the line is 2. Since the equation of the straight line has equation y equals mx plus c, the equation of this line is y equals 2x plus 2. Here's the gradient, and here's the y-intercept. Now let's find the area of the shaded region. So from part A, we have that the equation of this line is y equals 2x plus 2. So the area of the shaded region is the integral of 2x plus 2 with respect to x between the limits 0 and 4, as shown. This equals x squared plus 2x between 4 and 0. And this equals this expression shown here. We've simply plugged in x equals 4 in x squared plus 2x, and then taken away x squared plus 2x with 0 plugged in. Here's x equals 4 plugged in, and here's x equals 0 plugged in. And tidying up gives us that this expression is equal to 24. And now for the next graph. If we find the gradient of the line, we have change in y, which is 9 minus 0, over change in x, which is 3 minus 0. And this equals 9 over 3, which is equal to 3. So the gradient is equal to 3. Since the equation of a straight line has equation y equals mx plus c, the equation of this line is y equals 3x. Here's our gradient. And of course, because the line crosses at 0, we have that c is equal to 0. And now for the next part. From part A, we have that the equation of the line is y equals 3x. Let's now find the area of the shaded region. So we need to integrate this between the limits 0 and 3. So integral of 3x with respect to x between 0 and 3 will give us the area of the shaded region. And integrating this expression gives us 3 over 2 times x squared. And we have that this expression is equal to the expression shown towards the bottom of your screen. Here we've plugged in x equals 3 into this expression, and then taken away 3 over 2 times 0 squared. So plugging in, of course, x equals 0. And tidying up gives us that the area of the shaded region is equal to 13.5. And now for the last graph. Let's find the equation of the straight line. Again, we're required to plug in change in y over change in x. This is 4 minus 0 over 0 minus 1, which gives us minus 4. Therefore, the gradient is equal to minus 4. Since the equation of the straight line has equation y equals mx plus c, the equation of this line is y equals minus 4x plus 4, where 4 is the y-intercept. Now let's find the area of the shaded region. So from part A, we have that the equation of the line is y equals 4 minus 4x. So of course we need to integrate this between the limits 0.2 and 0.8 as given in the graph. And integrating gives us this expression here. So we're plugging in the limits into 4x minus 2x squared. Here's 0.8. Here's 0.2. And of course here we've plugged in x equals 0.8. And we're taking away this expression with x equals 0.2 plugged in, to give us that the area of the shaded region is 1.2. And now for the speed, distance, time discussion. The relationship between speed, distance and time can be expressed as the formula speed equals distance over time. A van travels for 50 minutes at an average speed of 20 miles per hour. Find the distance travelled. So let's solve this. We must first express 50 minutes in hours to be consistent with the units used for speed, miles per hour. Now 50 minutes equals 50 out of 60 hours, which is equal to 5 over 6 hours. So using the formula, we have distance equals speed times time. So plugging in the values, we have 20 miles per hour for speed and 5/6 hours for time. And this gives us that the distance is equal to 16 2/3 miles. And now for review exercise 3A. We are required to solve the simultaneous equations shown on your screen, which have been labelled equation 1 and equation 2. Let's take a look at the steps which are required to solve equations by substitution. First, rearrange one equation so that one unknown is the subject of the equation. Next, substitute this in the second equation to find one unknown. Then, substitute the known value into the equation to find the other unknown. And finally, check that the x and y values are correct. So let's solve this. We rearrange equation 1 to give 3x minus y equals 3 implies 3x equals 3 plus y. Notice we've added y to both sides. So therefore, of course, y equals 3x minus 3. Here we've simply taken 3 from both sides. Now substitute equation 1 dash, which is y equals 3x minus 3, into equation 2. So here are the key parts of equation 2, and y has been substituted by 3x minus 3. And expanding the brackets, we leave of course 5x as it is, and 2 times 3x is 6x, 2 times minus 3 is minus 6, and of course 16 is left as it is. Now we have an equation in terms of x's and constants, one equation and one unknown. So we can simply tidy up to give us 11x equals 22, and finally divide by 11 to give us x equals 2. Now we substitute in equation 1 dash to find y. So y equals 3 times 2 minus 3, because of course x equals 2. So we've substituted that here. And tidying up gives us that y equals 3. Hence the solution is x equals 2 and y equals 3. Finally, we can check by substituting the x and y values in the equations. So let's do that. Substituting x equals 2 in the first equation and y equals 3 gives us this expression here. Clearly, the left-hand side equals 3 and the right-hand side equals 3 as well. We can also check by substituting into equation 2. Here's x equals 2 and here's y equals 3. And of course the rest of the equation stays as it is. The left-hand side of the equation is 16, and of course the right-hand side of the equation is 16 as well. Therefore the values satisfy both equations. And we can confirm that x equals 2 and y equals 3. Before moving on to part B, let's remind ourselves of the quadratic formula. Of course, some quadratic functions are not easy to factorize. They can be solved using the quadratic formula. The solutions of the equation ax squared plus bx plus c equals 0, with a, b and c real and a not equal to 0, are given by the formula x equals minus b plus or minus square root of b squared minus 4ac all over 2a. Remember to put the equation in the correct format before beginning. So let's now have a go at review exercise 3b. We are required to solve 2x squared minus 9x minus 1 equals 0. So let's solve this. Plug in b equals minus 9 as shown into the quadratic formula, and a equals 2 and c equals minus 1 as shown, and a equals 2 as shown here. And then tidy up. So we have that x equals 9 plus or minus square root of 89 all over 4, which gives us that x equals 9 plus root 89 all over 4, or 9 minus root 89 all over 4. And therefore, x equals 4.6085, or x equals minus 0.1085. This brings us to the end of this session. If you have understood its contents, you should be able to find the gradient of straight line graphs, find the shaded area under a straight line graph, apply the speed, distance, time formula to real-life problems, and solve simultaneous equations and quadratics. Thank you very much for listening.